Okay, so what was the mass of your egg lander, including the egg? So the mass of our egg lander, including the egg, was about 0.1345 kilograms. And we figured that out when Mr. Copus helped us use the scale thing, and then we converted that from grams to kilograms. And then how much time did it take for the egg to reach the ground? Using the following object equation, d equals 1/2 gt squared. So for that we got 0.4518 seconds, and I found that by isolating t, and that got me 2d times 2d over g, and on all that square root. So I got 0.4518 because we know the distance already. We know the gravity, and yeah, so you can just plug this in and solve for that. So that's cool. What was the velocity at impact, and how do you calculate it? So the velocity at impact for us was 2.214 meters per second, and you find that by using the equation for velocity, which is distance over time. And then the momentum was 0.2977 kilograms meters per second. The impulse experienced by the egg and the change of momentum was 0.2977 newtons per second. It's just a change of momentum, and it's a negative impact. And then how much energy did your lander transfer to the ground? So for this one we got 9.8, which is about gravity, because our distance was 1 that we used everything to calculate for it, and then instead of 5 because we did it earlier, so we just did 1. And then what kind of collision occurred? Did it bounce? Our collision, we would call it elastic, because we're utilizing suspension, and so yeah, it bounced too, because when the blocks hit the ground it also bounced. And since it's not exactly the material is malleable, it was more elastic than inelastic. Estimate of distance of collision. So for us, we just said 1 centimeter because we also use the standard. So what is the impact force of the lander? For this one, we got 0.659, which is the formula. And then the time spent during impact, we got 0.415. That's including solving for delta t as the impulse / force. And then for the next question, it's why does increasing the distance or time over which the impact occurs lessen total impact versus the egg? And is it directly proportional or inversely proportional? So for our lander, it gave our egg enough time to transfer kinetic energy to the ground, and this time and distance are inversely proportional to force. How do a car's crumple zones and airbags reduce impact force to the passenger? So it increases the distance to give enough time for kinetic energy to transfer from your body to the car. And that's pretty much it. The best part about learning about engineering and design and doing this project for us was making the egg lander. That was definitely the most fun part, because we got to experiment with a bunch of different things after making our design and seeing what worked best. And yeah, here's our... Yeah, we're about to go test it. Yeah! Yeah!
You're on your camera? Look at it on multitasking. It increases the distance to give it.
Yay, yay!